Hey guys, welcome back. Hope you're doing well. I'm Dr. D again, and what we're talking about right now is statistics. What we've gone over so far is an introduction, kind of what, some definitions, what statistics is, and what it's the study of populations for those of you who missed it, but I have other videos, so go take a look at those. And also, we looked at data, right? What data are, where you get them, ways to think about them, different data scales, cross section versus time series. Just kind of some vocab so that we feel a little bit more comfortable, right? So that you're conversant with this stuff. Today I'm going to kind of try to tie up the introduction by talking about sort of what we do with statistics. So what we can do is what we're going to be talking about. What we really want to do with statistics usually is to study populations, as I said. And there are two real things that we're going to do with populations. One thing we're going to do is we're going to describe them as best we can. And the other thing we're going to do is we're going to make guesses or inferences about them. So we're going to go much more into depth as the video series continues, but for now, just want to kind of talk about what I mean. So let's take kind of a simple example. Let's imagine we had a bike shop, and I'm going to see how this works. I'm going to try to pull up Excel and do some stuff. What we have is we have the ages of our 50 customers over a single day in our bike shop. Come here, Excel. There you are. Okay, so we have 50 customers. And we can break them down by age, right? So we have different age groups. These are pretty standard. Sorry, you can see there we go. Some stuff. 18 to 24 is the youngest age group. After that, we got 25 to 34-year-olds. And let's do a frequency while we go along. So we had 11 of our 50 customers, 18 to 24. 15 of them were 25 to 34. People in their late 30s, early 40s, we had 10 of those. People in their late 40s, early 50s, we had 8 of those. Late 50s to early 60s, we had 4 of those. And 65 plus, we had 2 of those. Okay, so that's what we've done right here is kind of measure, right? For each person, we measured their age, each customer, and then we just counted them up. We'll talk more about how to develop a frequency chart in a little bit, or frequency table. But this is one of the good ways that we can use to kind of look at data. There are 3 different ways that we generally use. One is tables, and that's where we kind of summarize numerical information in one place. Another is graphs or charts, graphs. And this is where we visualize data. And then the last one is numbers. And these are sort of summary measures. They're a little bit different than tables because sometimes you can have just one number, right? Like the average age. That's just one number and it says something about your population, or at least about your sample. Okay, so looking at this table, we have a frequency table here. One thing we can do is we can add these up. Excel makes that pretty easy. Use equals sum parentheses, and then we want to include everything in here. So we got B2 all the way down to B7, and if I did it right, yep, we have 50 people. Okay, now that's somewhat useful. We have. It's much better than just say a list of the numbers that are the ages, because then you would have to go through and count them to figure out what was most common. And here we can easily see that 25 to 34-year-olds are the most common. Another way we could look at this is by using a relative frequency or proportion. To calculate the proportion, we take the frequency divided by the total, right? So 11 out of the 50 customers were 18 to 24. Now in Excel, I can just do that division very simply like that. The problem is that if I copy this and I paste it into the next one, it's going to give me a problem because as you can see here, this B8, that's my total. And when we go down one, B9, that's not existent. So we don't want the B8 to change. In Excel, we can do that by putting dollar signs in front of them. That tells you not to change things. So once we have the absolute references in there, we can just copy and paste this, and it works fine. Okay, because now we're dividing that. So 22% of our customers, 0.22, were between the ages of 18 and 24, 34% of our customers were, 30% of our customers were in their late 20s, early 30s. We can copy and paste these all the way down until we get to 100% there. If you want to depict this as a percentage, you can just click on the percent symbol up here, and it just automatically converts them. And there's a lot you can do to make this fancier, right? You can put some borders in. Here maybe a border, here maybe a border. And then get the things centered if you want. All that stuff is relatively unimportant. Okay, so that stuff's presented in a frequency table. And that's one thing you can do. Another thing we can do with this data, once we have it, is we can present this as a chart, as a bar chart. Right? So Excel also makes this very easy to do. Just to give you an idea what a bar chart is, in case you've never seen one before. Usually what we have is we have a horizontal axis here, and what we put down here is our categories. And then on the vertical axis, we have some measure of our frequency. Right? And then by category, we'd have, a category here that's that high, a category here that has this frequency, say another one here has this frequency, another one here has this frequency, and you can color these in if you want. That makes it very easy to tell which is the most common, which is the least common, without having to look at the numbers. Looking at the numbers is very useful, and having the numbers is certainly very useful, but when you want to know which one's the largest, you have to compare this 22 to everything else in the table, right? Or sort them somehow. Okay, so let's look at how to do this. If we select the ages and the proportions, go to Insert, Charts, Column. Chart is what we want. There we go. Let me move this up so you can see, everybody can see it. Okay, so this gives us our proportions, right? It's covering up our actual data. It's easy enough to change that. I don't actually like a lot of the ways that it presents the information automatically. And so what I'll usually do, when we only have one category, usually delete the legend. We don't need that. And you can change this to, let's say, customer ages, right? Because that's what these are. And I'll say n equals 50, just so I know how many people I have in here. These axes aren't labeled. That's never a good idea. That's easy to change. Layout, axis titles, give ourselves a vertical axis title and a horizontal axis title. These are the age bands. Age bands, there we go. And this right here, is the proportion. There we go. Now we know the stuff we need to know. I still don't think I really like the look of this, so there's some stuff you can do to format the data series. I like to reduce the size of the gap. But there should still be a gap here, right? Whenever you have ordinal data or nominal data, categorical data, right, for your age bands, for example, it's nice to have a gap in between. That'll be less the case with other kinds of data. And technically, I guess you could think of this as a histogram, so you could get rid of these. But generally, for whatever reason, this is usually treated as ordinal data. Because usually the information is reported, right? So lots of times when we do with histograms, we're dealing with arbitrary. We'll talk about histograms in a little while, but the statistician is making arbitrary divisions between groups. Here, it's likely that they reported it. They're a checkbox, so they automatically were categorized like that. In any case, this is a bar chart. It gives us some information about it. So we have a frequency table here. We have a bar chart here. And now we can look at some numbers. Let's say that among all these customers that we had, we collected our total receipts, right? So our earnings for the day, our revenue. The total was $2,422 from these 50 customers. Well, we could find the average expenditure, the average earnings per customer, just by looking at this. X bar equals the total, 2422, divided by 50. Right? If we divide that, we'll get, let's see, where is it? Here we go, 48.44 per customer. Right? So those are three ways to look at our data for this sample of 50 customers. We have their ages within the frequency table, and then we made a bar chart. And then we were able to calculate the average, which just gives us one number that summarizes some characteristic of the entire sample. Okay, so this right here, what this is called is descriptive statistics. And it's very useful, right? Lots of times what we want to know is just, what do our data look like? What do our population look like? Descriptive statistics tells us that, right? But most of the time we're not content to simply describe the data. Usually we want to do something more with it. A lot of times what we want to do is make some useful guesses about the data, right? So we know that 4844 is how much these 50 people spend, but how much does our population spend on average, right? Not just the 50 people we have. And when we start making guesses about things, particularly when we don't know the actual answer, right, or we don't have enough information, it's called inference. When we make guesses about a population, it's called statistical inference. So that's the other part. The two most important types of stuff that we're going to talk about involves whether the stuff is used to talk about a population, in which case it is a population parameter, right? That's something that characterizes a population. That would be like the average spending within the population, or measures of dispersion within the population, or the size of the population. And the simplest one of these is just the population size, which we usually denote with a big N. Okay. Usually we can't actually find out the population parameter. So when we make inferences, we're usually guessing about what the value of this is. What we can see comes from the sample. And the values that we collect from our sample that will help us understand the population are called sample statistics. This would be like this X bar, right? The mean spending within our population or within our sample, or measures of the standard deviation in our sample would be a sample statistic. Again, the simplest one here is just our sample size. Usually we use a lowercase n. Just a kind of heads up as to how to make heads or tails of these. Usually we use Greek for population parameters, or capital letters, I guess. Greek is common. Clearly this is not Greek, but if you see like mu or sigma, that's related to the population. Usually we use Roman symbols, like X bar or S or P, to talk about sample statistics. So, population parameters and sample statistics. These are the most simple ones, right? But usually that's not, we care about more stuff than that. For example, we might care about height or IQ. If our sample is, let's say, farmers, average rate of return on investments. Depends what we're interested in, but we care about a lot of different things. Discount rate, the likelihood that they'll buy a given product, favorite color. That would just be for farmers, right? If the population is rolled dice, right, because you're a gambler, what you want to know is the number of pips facing up on the die, on the top face, right? For some reason, that's what we care about with dice. We don't care about their shape or their size. We just care about how many pips are on top, not how many pips are on bottom. There are other things, right? If you're involved in transportation policy, you might care about the population of commuters in the Metro Atlanta area, and you want to know what kind of transportation choice they make, right? Who drives a car? Who drives a hybrid? Who drives a truck? Who takes public transit? Do they take a bus? Or do they take a train? Mostly for now, we're going to worry about numerical measurements. So that's what we'll be focused on for the time being. Statistical inference is where we take this stuff, sample statistics, and use it to make guesses about this stuff. For example, this 4844. If we want to know what the average expenditure within our customer base as a whole is, this is our best guess. Right? We don't actually know how much we expect to get from each person, but that's our best guess. It's always going to be wrong. It's almost certainly wrong. Right. Chances are that people actually spend, I don't know, 47.82 or 49.05, right? Maybe they spend a lot more, maybe they spend a lot less. But we know it's probably not $3, right? And it's probably not 3,000. And what we can do once we, get a sample statistic like this is, start tightening what seems reasonable, right? So if you had to guess, I mean, even without any information at all, you might have guessed that the average customer spends more than $3 if the cheapest thing in the store costs more than $3, right? We don't sell anything that's cheaper than $3. So if people are buying things, they're spending more than that. And if we don't sell anything that's more than $3,000, then that's certainly, if that's the most expensive bike in the bike shop, then certainly the average customer is not going to be spending that. But the more data we get, the tighter we can make those bounds on what we think will happen. Okay, so statistical inference, descriptive statistics, those are what we can do. And it's very useful, right? We can do it by hand. We're going to do a lot of it by hand because working with math, pencil and paper really is the best way to go. That said, in most business environments, Microsoft Excel is something that you're going to have access to and something you're going to be expected to know how to use. So I'm going to walk through Excel a little bit just to kind of give you an idea. Let's see what we have here. So here I have some data that I made up. Maybe I should hide the ribbon so I can get a little more screen space here. There we go. So here's some data I made up for a bunch of different cars. What we have are 17 used car sales from American Auto Sales in October 2011. Again, I made these up. Delete this. Work it out. And what we have here is we have a title bar, right? This has the file name and the title of the application. The thing at the top here, which I just made disappear, is the ribbon, and that contains stuff we're going to use, fonts, formatting. You can't see some stuff because it's behind my head, but we can insert charts. Showed you how to use that a little bit already. You can change the layout of the page to print it. You can work with formulas. I almost never use this because once you get to know formulas, you just know them. It's easier and faster to type them in directly, but they're available here if you want to look them up. You can, you can click the little drop downs and see all sorts of formulas that you might want to use. You can sort the data. You can filter the data. Yeah, there you go. These are already sorted by model, I believe. You can review stuff. That's, if you're working with other people. You can change the way you view it. There's a lot of stuff you can do with a ribbon. For now, I'm going to tuck it back up here. This area down here, this is the body of the spreadsheet, and this is where the data is entered, generally, right? And you can just type in any of these cells, and stuff will show up. Can contain numbers and words, and generally Excel does a pretty good job of knowing whether you want to store something as a number or as a word. Every once in a while, you have to fuss with it. And you have a year, make, and model, mileage, selling price, and gas mileage, right? So this is data that I've collected. Other stuff that you can see up the cells at the top row, this is the column references, right? So these are column references are A through really far, right? You can just keep going and the letters go up and up and up. A, B, A, C, all the way to Z, Z. And if you keep going, it gets to there are thousands of columns, X, E, Q. Okay, so we'll almost never use those. Similarly, going down, you have numbers. These are on the left side here. You have the row references. They start with 1, and they can go down, 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 down until you get to the very bottom, which is literally a million rows. Right now, we're only using 18 of them. There's a little bit of extra information that's readily available. Excel in the current version, it shows you the average, it shows you the count of them, and it shows you the sum right away. You can right-click and modify what you want to be there. Numerical count, minimum, maximum, all sorts of stuff. I haven't found much need to change them. Average, count, and sum, though, I use that kind of a lot just to take a quick look. Wait, what's the average of these? Oh, it's 1,045. Oh, yeah. So that's that stuff. Here is your formula bar. This is where it shows you what is entered in the cell, and it will show you the actual thing typed into the cell, whereas in the cells in the body it'll just show you the value. For example, if you want to add two numbers, you can write equals 2 plus 2 and it'll show you 4, but when you hover over it up here in the formula bar, it shows you the original formula, how that's calculated, right? So handy. Okay, so that's just a basic walkthrough of Excel. Excel is very useful because it allows us to do all sorts of stuff. In addition, we can not only can we select one thing, but we can select a range of things, and I'll show you how to enter those by hand. Let's consider the case where let's calculate, for example, the average mileage of these cars. Right, these are all used cars. We want to know, what the average is. Well, let's say we're right here. We want to calculate the mileage for the cells above. Easy enough. Equals average. Which kind of annoys me as somebody who teaches statistics that they don't call it a mean, because this is the mean, but yeah, so we want the average, and we want the average from cell D2 to sell D18, and you can just type that in instead of selecting it. It doesn't matter what case it's in, D2 to D18, close parenthesis, hit enter, and it'll tell you. The average of those is 119,136. So these are pretty well used cars that we're talking about here, right? They all have more than 100,000 miles on it. One of the nice things, as I've kind of shown you a little bit, is that when you copy and paste this, it'll automatically give you the average of, it'll just copy and paste the entire formula. So it'll give you the average selling price, the average gas mileage. Now let's say we didn't want to know what the average selling price was, we want to know how much they sold for in total. That's easy enough, it's just equals sum. E2 to E18, $17,776 for $766 for these 17 cars. So they sold for about 1,000 a pop. You can also just divide this by the count of these cars, right? How many prices there are, and that'll tell you. That's another way to calculate the average, right? You can just do it by adding them up and then dividing by how many there are. Okay, so Excel formulas are really useful. We'll be using Excel to enter data, to manipulate it, to analyze it. Just wanted to kind of give you guys an introduction. These Excel formulas are incredibly useful. I use them all the time. They can help you by very powerfully and quickly calculating stuff. That said, it's not a substitute for knowing how to do it, right? So being able to use formulas, you still have to know how to get an average. You still have to know how to add a set of numbers. It's just that when you're adding 17 numbers, all with 4 digits and 2 decimals, 4 leading digits and 2 decimals, or 3 in some of these cases. I don't want to do that by hand. You don't want to do that by hand, right? We don't have to. Just because you can doesn't mean you have to. And I could, right? 5 plus 8 is 13, plus 8 is 21, plus 3 is 24, plus 5 is 2 5s is 34, plus 8 is 42, 45, 48, 58, 68, 76. Clearly, I can add a column of numbers. Carry the 7, do it over again. It's just not. Well, it's a little fun. It's just not that fun, right? And especially if you have to get your homework done, it's a lot faster to do it. That said, on exams and stuff, you're not going to have access to this stuff in my class or whatever class you're watching this for, or in your job, you will have access to it though, so you should know how to use it. Okay, so that's Excel. That's just kind of a brief introduction. We'll be using it more. I'll be showing more videos about it. Last but certainly not least, I just want to talk about ethics a little bit and responsible use of statistics. I've said before, what we really care about is meaning. So we're using data, and we're analyzing it. What we're trying to do is to create meaning. The reason we want meaning really is we want truth, right? We want to know what's really going on, and so we're getting truth about how the world looks. The reason is you don't want to, stumble off a cliff. You want to know there's a cliff there, right? You want to know what stands in your way. You want to know what's going to be likely to work. And as long as this stuff is done in an intellectually responsible fashion, right? So intellectual integrity makes this all possible. But it's possible to do other things, right? To not, this is honest analysis. But there's dishonest analysis, right? You can cherry pick the data, right? You can just keep getting samples until you get the number you want to see. So there's cherry picking the data. Another thing would be doctoring it, right? So this doesn't look exactly like what I want it to, so let's modify it. Cherry picking is less, they're all egregious. Cherry picking is a little less egregious because then doctoring, you're actually modifying the data. Another would be confirmation bias, where you only look for numbers that tell you confirmation bias. And confirmation bias is kind of the thing that drives cherry picking. You only look for numbers that tell you that it's true. That what you want to believe is true. There's another name for all this stuff, right? That name is lying. And when you lie, you can't get here, right? You can't get the truth about how the world looks. In some cases, this is bad because it misleads your customers. In many cases, it's bad because you're not going to get the right answer, right? You're going to get the wrong answer. You can make bad decisions. But it's also bad just because it's bad, right? Because intellectual dishonesty is bad. You're not using data to find out more about the world. You're not helping people. Fudging the numbers might not seem like lying, but it is. And it's unethical, right? You shouldn't do it. And you should be careful about it. The best way to do this is to have transparency in the process. Let other people see your numbers. Make them readily available. You have deeply held ethics. And then have other people hold your feet to the fire, right? Allow criticism. If possible. If all this stuff is possible, that's the best way to do it. The problem is sometimes this isn't possible, right? I mean, if you work for a federal agency, sometimes you can't be transparent because you might be working with classified data. If you're getting data from somebody else, you don't know for sure that they have deeply held ethics. And so criticism is really important. It's the reason that we have peer review in the social sciences. The more the groundwork for your analysis must be kept secret, the more important it is to make sure you hold yourself to a really high standard. But if you do that, then you can really learn a lot about how the world looks. Okay, so that's an introduction to statistics. That's that. So we talked a little bit about data. Before that, we talked about what statistics is, and after that, we talked about what we can use statistics for, to describe, to make guesses about the population. I'm going to be using Excel as a tool, and hopefully everybody will be doing so ethically. If you have any questions, as always, post a comment, send me an email. I'm happy to answer. I'll be posting some videos with some practice problems soon, and then we'll be moving on. We'll be talking a little bit about, more in depth about how to create visualizations, and then we'll move on to numerical measures to summarize statistics, summarize data. Thank you guys very much. Hope you're well. Keep in touch, and I'll be back.